Okay? But I didn't even erase anything. Just turn the camera off and on. I call this part B. Right? So you did it filling in numbers. And the problem, you know what, for the problem, that's actually not a terrible way to go. It says if this is equal, then show that those angles are the same. Now let's see how we could do it without filling in the numbers. I don't mind your way of doing it, but it does seem to want it to be proved in general. So from your way, it looks like this triangle, WZX, I probably shouldn't have erased them. WXZ is going to be similar to this triangle, WZY. Right?
Yeah.
Not Y, WZY there. Because we're trying to show that the WZX, this angle, we're trying to show this angle is equal to angle WYZ. Okay? And that's the question mark. But what we do know is this relationship. WZ squared equals WX times WY. Okay, so I'm going to transform this, first dividing both sides by WZ. So I get WZ equals WX times WY over WZ. And then maybe I'll divide by WY.
Alright.
So WZ over WY equals WX over WZ. So what does that tell me? WZ to WY, this side to this side, equals WX to WZ,
yeah.
that side to that side. And as you pointed out, ZWX
They share that angle.
is the same as
ZWY.
ZWY. So this angle and that angle are the same. So that relationship up there, that squared equals that times that, turns into two
The
ratios. Pretty neat, right?
Yeah.
So it turns into exactly the ratios you found.
But with numbers.
You found them with numbers. So WZ to WY is the same as WX to WZ. Bam, 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 bam. They share an angle. That is the definition of side similarity. It means these two triangles are similar. It does mean, indeed, that those two angles are the same. Make sense?
Yep.
Okay. So that trick of turning a square equaling a product into two ratios, which is just cross-multiplying, right? It's sort of uncross-multiplying.
Yeah.
All right. Good job. Good job working through that problem.